Hello, everyone. Welcome to our class. Today, we are talking about a very special topic for this course. It's like an instructor, like a selected topic. It's not 100% like related to our computer system principle, but it's definitely a good information you might want to know before you go to other class. It's about Rust, these programming languages, a totally new languages programming languages, but it's very interesting and very useful. So I hope you will like it. So what's a Rust? Actually, Rust is not so like a the idea of Rust, this language is not so new. It's still a statically and structured typed system programming languages. So it's like a C. You need to in Rust languages, each value has its type, and most of the time you need to kind of follow this type. You cannot easily change the type of a variable. We will show you some example later, but you can imagine that it's a statically and strongly typed programming languages like a C. But it also provides a lot of flexibility to users. And even though it's strongly typed, the users can easily use this variable compared to C. We will see the example later. Even though it gives the user a flexibility to do something, it can still be optimized for maximum performance as the C languages. So it's still a system programming languages like C, because the performance is really good. It can be optimized to a very good performance like a executable file. But it also gives some flexibility to the user. Okay, so compared to C, as a programmer, you will feel like it's easier to write the code for Rust, but you don't need to worry too much about the performance. And also, the benefit for this Rust is it provides the memory management for a programmer. So in C, I think the painful like a lot of students, a lot of you might feel like it's really painful to manage the pointers. You need to allocate it, you need to free it, you need to take care every this memory management by yourself, right? And if you fail to do this, you might get segmental fault, or you might get some like just like allocate too many memory and run off your memory space. So in this case, in the Rust, it provides some memory management for a programmer. So it's not like 100% like a garbage collection. So in some other languages, that's a garbage collection. It's not, but it provides some way to manage the memory, and we will talk about this later. So you can see it's kind of okay. This is a system programming languages, but you try to give the user some easy way to write a program. Okay, so this is the idea. So what's a pro to choose Rust compared to C languages? The pro, what's the advantage? The advantage is because there's an easy memory management. So still, the programmer might feel more comfortable to write the code. Also, it provides a higher level abstraction. It provides a tuple. It provides some like a automatically assign the type. You don't have to specifically to tell what's the variable type. They will figure out what the type it is. We will see some example later. Okay, so which means it's really like it's really convenient. And also another big like advantage of this language is it's much safer for what? For if you want to do a parallel programming. If you want to do a parallel programming, in other lecture, other like videos, you should see you need to deal with the rest condition. You need to deal with the shared variable, this kind of concept. You need to take care of this, right? But in Rust, because it's used a different way compared to C, it's used a different way to manage this variable, this shared variable, or this like memory. So it's much safer to be checked. Like it's much safer for this memory because the memory access are automatically checked by your systems. So this is a benefit. What's the count size for this one? Let's small overhead. For example, in C, you probably use the integer to represent the index of an array. But here in ROS, there's a different integer, and some integer is like a larger than another one. They use a larger one to as an index. So let's a small overhead, space overhead on this. Even though it's the executable file you compile can be almost like the executable file from C languages, but it might have a small overhead, just small, and less flexible during the coding in some way. For example, why? Imagine that you want to do a thread programming and you want to share a variable. Because it's need these programming languages try to check the memory access automatically. So it might not allow you to do some assignment or some like a manipulation of specific variable, even global variable. It's my control it. So the count size compared to C is like okay, less flexibility on this parallel programming coding. So it's like a trade-off. The pro advantage is much safer. The cons is giving you more restriction on this parallel programming. So this is the pros and cons of the Rust. Okay, so if you understand the Rust here, what's the Rust programming languages? We will talk about the Rust in some kind of different concept to introduce these languages. The first one is about a type. The Rust is still a statically typed programming languages, okay? So it still have a type. So what's the type it can have? It can have a primitive type, Boolean character, i32, 32-bit integer, 64-bit integer, and it has a lot of like different size of integer. And also it's provide an array. Also it's apply tuple. Something like some like special type like a C, we have a structure, right? With structure, it's also supplied. So you can see there's not so many difference between the type in Rust and type in C. And for pointers, it still provide pointers. So you can use the pointers, the reference, you can use the functional pointers, and so on. So for the type parts, it's actually like a lot of C type is implemented in the Rust too. So, but the Rust also provides something like something you cannot see this in the C, like a tuple. Tuple is very convenient way to abstract your type. So this is one a good way to write the program, easier for the programmer. Rust supports generic type, data type too. So there's no problem to have a generic data type in your program. So this method, this function support integer, also support some other like Boolean, support different type. It's still possible in Rust. Okay. So let's look at the variable. Let's look at variable. How we write the code? How we write the variable in Rust? This is one example about a variable. Actually, you can see the first benefit. What's the benefit to use Rust? You don't need to say this X is integer. You don't need to say this is a character array or string. You don't need to say this is a Boolean. You just use let. Let the variable equal to some value. Then the compiler in Rust will figure out what's the value of this. It will check, okay, this is an integer. So it's give the X, assign an X to an integer. This is character array. Actually, it's a reference, the pointer, right? So there's a reference to the string here. So it have something like this. This is a Boolean. This will get the Boolean. So it still have a type. The Rust is still typed programming, but you don't have to define a type when you use a variable. This is a huge benefit. So you can just define a variable with its value, then these programming languages, the compiler will try to find the type for you. So this very good benefit is give a programmer an easy way to write the program. Okay, let's look at this example. If we define x equal to 5, then we print out this should be 5. We assign x equal to 6. We try to print out 6. What happened? This code will now be compiled here. Okay, so you will get this error message. It said you cannot assign twice to immutable variable x. Okay, so immutable means what? Means this variable cannot be changed. The value of this variable cannot be changed, right? So why we see this error message? Because of what? Okay, so in Rust, it's giving you some flexibility. You don't need to define the type. What's the type of this variable? You don't need to define it. But it's also reduce some flexibility, like you can easily change the variable, because if you change a variable, you need to let the compiler know this variable can be changed. In Rust, by default, all the variables are immutable. You assign a value to the variable, then you should not change it. You should not change the variable. That's the point in Rust. In Rust, it's assumed all the variable is immutable, and you should not change the value. It's much safer because it can help your compiler, Rust compiler, to manage the memory correctly. But it's also can give compiler the flexibility to decide what's the type of this value. So the Rust assume all the variable by default they are immutable. Okay, so if we want to change a variable, let's say the x equal to 5, we really want to change a value. How can we do? Here is the example. We need to define the variable is a mutable variable. Okay. So in this case, after you run this code, you can see we got the 5 and 6 here. If you tell the compiler x is a mutable variable, then you can change your value. You can change your value. So we assign 5 to this variable, and we change it to 6. It's good. It's perfect. So this is very different to C. In C languages, they do not. You can change this variable. If you don't say the constant, if you don't say it's a immutable variable, then you can always change it. But in Rust, it's totally upside, different. In Rust, it's assumed it's immutable, except you tell the compiler this variable is mutable, then you can change it. This is a big difference between C and Rust. Okay, I hope you got this idea. So here's another example. We try to assign the x is immutable, but what happened here? We assign it to 5, but after we assign it to 5, we try to change it to a string. This causes problem actually. You can see this causes problem. It cannot find this address of the particular your character array. So it's a pointer. You can see this actual pointer. It cannot change the type of this variable from integer to pointers. So even though the benefit of this Rust is that you don't need to say what's the type of this variable, but it doesn't mean you can change the type. The type is still there. The type is still there. So when you assign the first value, they will, based on the first value, to decide, okay, what's the x type? X type should be I32. It should be an integer. If you try to assign a value to this variable with I32, it will tell you, no, this is not something you should do, because this program is still a static type programming languages. Okay, so again, it's still static type programming languages like C. So you cannot easily change your variables type by doing that. Okay, So this is something you need to pay attention. If we want to change a value, for example, we want to change the x to hello, this kind of stuff. The only thing we can do is we can actually redefine a variable. So in C does not allow you to redefine. You cannot say integer x equal to 5, then integer x equal to 6. It's well, the compiler will tell you, no, you cannot duplicate, redefine it. But because of the design in Rust, Rust want to give the user, the programmer, a flexibility to write the code. So you can redefine a variable. In this case, x will become hello. Actually, in this case, this x is get rid of when you have another x. Okay, so the program, the compiler will figure out, okay, there's 2 different x here. The first x is number 5. The second x, I try to redefine it. So actually, you can redefine it. In this case, you can say, okay, the second x equal to hello, because this x is I32, but this x is just a reference, a pointer. So this is the difference. Even though the x variable is the same, there's the same name of the x. They both call x, but you can redefine it. X now is become a pointer. So which means after this line, you don't have any x information for this first x. This is in Rust. So in Rust, you can redefine a variable. So I hope you like today's video. Today, we briefly introduce the Rust programming. What's the difference between Rust and the C languages? What's the benefit and disadvantage to use Rust over the C languages? And we briefly talk about the variable. Even though the Rust is a static typed variable, like a programming languages, you need to, each variable has its type. But the Rust has some like a design to allow the programmer to write the code in more flexible way. But also, because the Rust want to maintain the performance, also maintain the memory access automatically for the user. So the Rust also gives some restriction, and the programmer need to follow this restriction to write the code. Okay, so I hope you enjoyed today's video. I hope you like the Rust, these new system programming languages. We will talk about other like a concept, other like a related topic in the Rust in other videos. I hope to see you in other videos. Okay, so that's for today. See you next time. The Rust programming is interesting.